Welcome, dear children, to our next mathematics class. Today we'll be doing prime factorization. But before we do prime factorization, let's quickly do a recap of our last class where we had done prime and composite numbers, twin primes, and perfect numbers. Now, prime numbers are those numbers which have only two factors, 1 and 7. Like 7 is a number which has only two factors, 7 and 1, isn't it? So, it is a prime number. Composite numbers are those numbers which have more than two factors. Like for example, 25 has 1, 5 and 25 as factors. So it's a composite number. Then twin primes are prime numbers which have a difference of 2. Like 11 and 13. Both are prime numbers and 13 minus 11 is 2. So they are twin primes. Next you have done perfect number. A perfect number, when can you know a number is a perfect number? Find all the factors of that number and you find the sum of all the factors. And if that sum is twice the number, then we say it's a perfect number. For example, I had given you 6 as a number. Factors of 6 were 1, 2, 3 and 6. When you add up 1, 2, 3 and 6, you get 12. And 12 is also 2 times 6. So it is a perfect number. Then I asked you to express some numbers as a sum of two odd numbers, a few numbers as a sum of two odd numbers. For example, I had shown you that 44 you have to express as a sum of two odd prime numbers. So 44 is equal to 1, I got 37 plus 7, both are prime numbers and both when added gives you 44. You can also write 41 plus 3. So you can select any two prime numbers whose sum gives you the number in the question. Now here you have to see the question properly, whether it is sum of two odd prime numbers or sum of two prime numbers. If they say prime numbers, you can give any prime numbers including 2. But if they say odd prime numbers, then you cannot put 2 there. You cannot use 2. 2 is an even prime number and it is the only even number that is prime. Then also there's another question which I've given you. Express a number as a sum of 3 prime numbers which are odd. So here we cannot use 2. Now suppose 21 I've done for you in the last class where I have used 21 is equal to 3 plus 5 plus 30. So there are 3 odd numbers, 3 odd prime numbers which are added to give you 21. So you have to find out prime numbers whose sum gives you the number in the question. So you see the question, what kind of prime numbers they want, whether it is sum of 2 odd primes, whether it is sum of 3 odd primes, or whether it is sum of 2 prime numbers. Just see what is in the question and follow accordingly. Today we will do prime factorization. Now the prime factorization, since you have already done prime factorization, but still I would like to go back on it once more on the basics of prime factorization. Like what exactly do you mean by prime factorization? Now when you see the word or hear the word prime factorization, prime means the prime numbers and factorization involves factors. So you can remember in that way. Factorization involves factors. Now, prime numbers can be considered as building blocks. Now, this is not the definition of prime numbers. It is just for you to understand in context to the prime factorization. And like suppose you know what are building blocks which children play with, isn't it, to make certain structures? So similarly, The prime numbers can be considered as building blocks, and composite numbers are composed of prime numbers. Now here I've shown you some examples. I've made two columns, prime numbers and composite numbers. So in the prime numbers, I've written a few prime numbers, 2, 3, 5, 7, 11. You can write 13 and next 17 and so on. And there are composite numbers, 4, 6, 8, 9. All these are called composite numbers because they have more than two factors. Now 4 has, what are the factors of 4? 1, 2 and 4. Factors of 6 are what? 1, 2, 3 and 6. 4 factors are there, isn't it? So these are called composite numbers. Now why did I say building blocks in context to prime factorization is because when I see 4, 4 can be expressed as 2 into 2. So did you observe here 2 into 2? 6 can be written as 2 into 3. And these are all prime numbers. And they are combined as a product to give you this composite number. Where next composite number is 8. 8 is equal to what? 2 into 2 into 2. What is 9 is equal to 3 into 3. Similarly, you see all the composite numbers are expressed as a product of different prime numbers. Isn't it? So, in context to that, you can say prime numbers are building blocks which are combined as a product to give you composite numbers. Now we come to prime factorization. Now here you have to see that when I say prime, we refer to prime numbers, and factorization is factors. So something related to factors, isn't it? Now when I say factors of 12, we have already done how to find all the factors of 12. And you'll get 1, 2, 3, 4, 6, 12. Isn't it? These are the factors of 12. But factorization and factors are two different things. So don't confuse it. That is why I've given you the difference. Factors of 12 are these. But factorization is a different thing. Factorization is the product of factors. When it is expressed as a product of factors, like 12 is equal to 1 into 12. This is 1 into 12. Can you see? Or you can write 2 into 6. Any one you can write, isn't it? Or you can write 3 into 4. You can also write 4 into 3, but commutative property shows that 4 into 3 and 3 into 4 are same. Similarly, 2 into 6 and 6 into 2 are same. So I have written only these. So factorization of 12 can be any one of this. Is it clear, all of you? You have read only one of these ovals. So what does exactly prime factorization means? Product of prime factors. So factorization means what? Product of factors. And prime factorization means product of prime factors. Okay. Now what is prime factorization of 12? Now this is a method called factor tree method. Prime factorization of 12. I write 12 here and then we branch out. So first we select the first prime number 2. Okay. So when I write here 2 and the other branch will be 2 into what gives you 12? That is 2 into 6 gives you 12. So after this, so 12 is 2 into 6. Now 2 is a prime number, so there are no more factors. You have only 1 and 2, isn't it? So we just write that straight away 2. We don't write 1 into 2. We just write 2. And for 6, it's a composite number. So we can branch out, and branches are always 2 branches. So we write 2 into 3 gives you 6. So finally we get 2 into 2 into 3 is 12. Now here 12. Now 12 you can also write 3 into 4. 3 is 3. It's a prime number. You bring it as it is. And 4 is a composite number. So 2 into 2. So that gives you 3 into 2 into 2. So if you observe that prime factorization of 12, whichever way you do, ultimately you arrive at the same result. 12 is 2 into 2 into 3. Is it clear, all of you? So whichever method you do. Now prime factorization by division method. Okay. A number expressed as a product of prime factors is called prime factorization. So this is the definition of prime factorization. Now here the important things to remember is, these are things you already know, but still I've given you once more, just to keep in mind that in prime factorization we use only prime numbers, that is only prime factors. And preferably, generally we take 2 first. When we are factorizing, we take 2 first, then 3, then 5 in ascending order. There's no hard and fast rule, but usually we do that way. Now division continues till we get 1. I'll explain to you with an example, and the number given is written as a product of its prime factors. Okay. Now find the prime factorization of the following numbers using division method. Now this is division method. Number A, 105. So 105 we write it here, and we have to find the prime factorization. That means, first of all, we'll check whether the prime factor is 2 a prime factor of this. So being an odd number, 2 is not a prime factor of this. Next prime factor is 3. So check whether 3 is a prime factor. So 1 plus 0 plus 5 is 6. So 6 is divisible by 3. So 105 will be divisible by 3. So 3 is a prime factor of this. Now, divisibility test is very helpful in finding these values. Okay. So now when you divide by 3, now since you know that it is divisible by 3, 3 is a prime factor of 105. So what do? We write 3 here and we divide here. So this is actually, we are doing division, but we are writing the quotient here. So 3, now 1 is smaller than 3, so we take the next digit like in division. So we get 10 here. So 3 3s are 9, isn't it? 10 divided by 3, what do? 3 3s is 9. So we write the quotient 3 here. Now we write 3 here, but here I've just used a pencil to show you. We should not write this 9. Just for you to understand, it should be done mentally. So 3 3s are 9. Here we get 1 as a remainder. 10 minus 9 is 1. That 1 will go here, combined with 5 to give you 15. Now, how many times 3 is 15? 3 5s is 15. So can you see I've done here 3 3s are 9. So it gives you 9. So 10 minus 9 is 1. The remainder 1 combines with this 5. Then 3 5s are 15. Now again this 35, now we know it will not go by 2, isn't it? Because since the first time only this was odd, so it will never be divisible by 2 anymore. So you check by 3 again. So 5 plus 3 is 8. So it is not divisible by 3. So next prime number is 5. So 5, 35, 5, last digit is 5 or 0, then you can divide by 5. So 5, how many times is 35? 5 7s are 35. Next you get 7 here. Then again you draw this. Then you write 7. It will go by 7 only now, isn't it? Next prime number. So 7 1s are 7. So this is how you do it. Okay. And finally, how you express 105 as a product of prime factors. 3 into 5 into 7. So this will give you 105. When you multiply 3 into 5 into 7, you get 105. Next is 1260. Now, this is an even number, so it is divisible by 2. So 1 is smaller than 2, so we take 12. I've underlined it. 2 6 are 12. Now there is no remainder here. So we take 6 here. 2 3s are 6, no more remainder. So 0, 2 zeros are 0. Now again, this is an even number. Again, we write 2 here. 2 3s are 6, no remainder. So we take 3, 2 1s are 2. There's a remainder 1. 3 minus 2 is 1, isn't it? That 1 will combine with 0 to give you 10. So 2 how many times gives you 10? 2 5s are 10. So I write 5 here. 2 5s are 10. Now 300, I got 315. 315 being an odd number, it will not be divisible by 2. So the next number that we will check is 5, 3. Now we know that 315 is divisible by 5 because the last digit is 5. But we will have to check after 2, next prime number is 3. So 3 plus 1 is 4, 4 plus 5 is 9. So the whole number is divisible by 3. So we will write here 3. Now 3 ones are 3. Next you have 1. 1 is smaller, it won't go. But if you have to combine with 5, then we have to put a 0 here. You can divide 315 by 3 and check whether you get 105 or not. Otherwise, see 3 ones are 3. Then we get only 1. And 3 zeros are 0. So 1 minus 0 is 1. That 1 will combine by 5, will give you 15. 3 5s are 15. Now 105, again you add up, you'll get what? 6. 1 plus 0 plus 5 is 6. So again it will be divisible by 3. So now in the beginning, 1 is smaller, so we can take 10, isn't it? Without putting a 0 here, we can directly take 10. 10 divided by 3, you get how much? 3 3s are 9. Then again 1 will combine 15 here, 3 5s are 15. This part is similar to the first sum. 5 7s are 35, 7 1s are 7. So 1260, when you have to prime factorize, this is the answer. 2 into 2 into 3 into 3 into 5 into 7. So this is what we write here. We don't write 1 because it is not a prime factor. So in HCF, when there are no common factors, then 1 is ultimately going to be the common factor. That I'll explain to you when we do HCF. But in prime factorization, we omit 1 because it is not a prime number. So we just write the rest. Now these sums you'll do in your class 1 copy. Prime factorize using a factor tree. So you'll write 28, then you branch out 2 branches from a number, okay? Here also 2, first will be 2 branches. Now 75 also, it's an odd number, so 2 cannot be the first one, first prime factor. So check with 3. If 3 is a prime factor, then 3 into what will give you 75. So you check it that way, okay? Now the next one is find the prime factorization using division method. So division method for 175, first you check with 2. So it's an odd number, obviously. 2 is not a prime factor of 175. Then you check for whether 3 is a prime factor. So 7 plus 1 is 8. 8 plus 5 is 13. So it is not divisible by 3. Next prime factor is 5. Next prime number which you have to check is 5. So it is divisible by 5, isn't it? So you write here 5 and you divide. Then you check by the next number, next what prime number will come and so on. Now all these you tried. Now this being a bigger number, you may get stuck in between 20,570. What I want to tell you is that first, obviously, you can divide by 2, isn't it? Because 2 is a prime factor. Then, so when you divide by 2, you'll get it. Then next, when finally you don't get an even number, check that number whether 3 is a prime factor of it or not. If 3 is fine, do it with 3. Again, suppose sometimes it may be that finally you're not being 3 is no more a prime factor. Then you check with 5. After 5, you check with 7. Suppose 7 is not a prime factor of that number and you still have numbers which you need to factorize. Then check with the next prime number, that is 11. So I'm giving you a hint. Finally, you're going to get 11. Again, suppose after that, finally at one point of time, 11 may not be anymore a prime factor of that particular number. So you have to check with 13. After that it's 17, after that it's 19. So like that you have to continue till at the end you get 1. Okay, and then express as a product of prime factors. So children, I expect you to do all this in your classwork copy. Those who are regular, fine. Those who are not regular, it's high time that you start doing your work on time. Before the next class starts, complete these sums and also exercise 3.5 number 456, write the question and do the solution. Till then, bye-bye.